What's this? 500. Yeah, the initial speed. So they just tell, I'm just writing that down so we know it, okay? That is the initial speed. In this case, what's the direction? How do we figure that out? What? Yeah, so we need to find how far over and how far up it goes, right? The angle is 30 degrees. Okay, so what do we do? Yep. And the vertical, exactly. Yep, yep. Anybody come up with that?
V naught xi plus V naught yj equals the total of 500.
So you know that V, what?
The initial speed.
The initial speed, yeah, times.
So V naught xi plus V naught yj.
I'm trying. It's hard to communicate that verbally.
Put them in order and put them.
So 250 root 3I plus, yeah, because we did I, plus what? 250 J, and what's that equal?
I think it's bad.
What is that? V?
No, it's not.
V what?
0.
V of 0, right?
The initial speed.
Is that correct? And you'll generally see it written out. They'll like to factor out a 250 like this. Generally speaking. It's okay if you don't. I get it. That's fine. Okay, hold on. I'm going to put this in here. This right, just so you know, this is the vertical velocity. I like this. This is a cool method. I like this a lot. Vertical velocity. Yeah, exactly, right. So we want it to be 0. Why? Why are we looking at it when it equals 0?
When it hits the ground.
No, it's not. Stop that. It's going to hit the ground. Wait, is it the velocity going to be 0 when it hits the ground?
No, it's going to be. Well, it will be.
This is we're interested in where it reaches the highest point, right? Highest point, either velocity is going to be 0. Why?
Because it's going to fall.
It doesn't go up or down, right? It doesn't go up or down. And then we'd have to make sure of that. I mean, theoretically, can a particle have a 0 velocity but then keep on going up? For a split second.
Really?
X cubed. At the origin. What's the rate of change of x cubed at the origin? 3x. At the origin, it's 0, right?
Yeah.
But does it then keep going up?
How do you have a projectile?
I'm not. I understand that, but just given it's a rocket ship with some sort of weird trajectory. My point is, just because the horizontal velocity is 0, does that guarantee that you have a highest point? No. What did you do in BC calculus over and over again to prove that it's the highest point? Yeah, first derivative test or the second derivative test. It's trivial. I understand it's trivial, but in this case you have to just remember, just because the derivative is 0 doesn't mean it's a highest or lowest point.
Oh yeah.
Remember that? Yeah. It's important. So in this case though, if we want this to be 0, t is going to be what? Negative 250j over what? Hey, at least it's positive. That's nice. So in this case, we think the highest point is going to happen when what? T is equal to? Yes, I understand you really want it to be 25.
250 divided by 9.8.
Yeah, so it's around 25.510. Okay, I'm going to check to see if that actually... Yeah. 250 J, yep, keep track of that, sure.
Plus 9.8 t.
Not minus.
Minus 9.8 t.
Minus 9.8 over 2 t squared.
Plus c.
Plus what?
C.
Equals. This is the position. S. Yeah, I'll put the J in. Give me a second here. Sure. So that's the vertical, right? Okay, so here's the question. How do we figure out what CJ is there? Well, where are we firing this projectile from?
Origin.
Yeah, we know that the position, the vertical position at time 0 is going to be what? 0. So that means that CJ it exists. What is it? It's 0. It is 0, which is nothing. I get that, right? So therefore, our vertical position in terms of time is going to be 250 TJ minus 9.8. Yes, I understand you want that to be 5 over 2 t squared j. Do we have a time at which we know? Yeah, we have a time. So we want to plug in t equals 25 point what? 5.1, right? When you plug that in, you end up with, I'll just tell you, you end up with a maximum height of around 22 kilometers, I think. Oh, that's the range. I'm sorry. The maximum height is about 3.2. Sorry, 3.2 kilometers, because you get thousands of. This is in meters, right? Okay, we're good with that. So this is the height, but it asks you for the range, right? So that's the max height. Okay, so we don't have the range yet, but we know at what time it's going to hit 0.
You need a velocity.
Or you could just, since we have the peak of it, you could find this distance and double it.
You could find that distance and double it, but how? Okay, I have a question for you. This is important. How do you know you can do that?
It's
Because it's,
parabola. So
How do you know it's a parabola?
Because it's a projectile.
Okay, okay. I need you not to say things like that. Yes, I understand that, but how do you prove that it's a parabola?
Position.
Yeah, the position function right here. Just take a look at this. We know that this is a parabola, so therefore it is symmetric over its peak. It's symmetric over the vertical line that passes through its peak. So we know that this thing hits ground at 2 times 25.51, so at approximately 51.02 seconds, right? We know that's when it hits ground. So does that help?
Yeah.
Sure, absolutely. So, but part A is asking specifically, so this, therefore, how do we figure out what the range is? Times the x component. Yeah, times the x component. We need to figure that out. Do we have the vertical component? Have we done anything with the horizontal component yet?
Yeah.
We did at the beginning. So back here, what is the horizontal component going to be? 250 root 3, right? Do you agree? 250 root 3 is our horizontal component. So what should I write in order? So what should I write first here if I'm going to do this? Vxt is going to be what? 250 root 3 times what? And that's not t. What is that? That's Vx at 0. Correct. So if we want to actually find horizontal position, what do we need to do? This plus, so 250 root 3I plus the integral from 0 to t of what? Which is what? Is there any force acting upon this besides the initial? No, there isn't, and let's say du. Great. So this right here is Vx of t. So what's this going to be? Vx of t is 250 I what? Plus what? Plus c? Is that correct? Okay, so what do we do now?
Why do you have
C is going to equal 0.
Oh, it equals. Well, is there a c there?
Doesn't it erase it out?
It's gone, right? It could be a constant number.
And then you plug in 0.
Okay, but we know that Vx of 0 is what?
0. 250. So it says C equals 0. Oh, right.
So Vx of 0, but I have a question here. This right here, what do we do? Like, I'm confused for a second. You need to explain this to me.